Telescopes kept getting stronger, and the expectation seemed simple. The farther astronomers looked, the more clearly the universe should reveal itself. Then, in 1998, a set of observations refused to cooperate. Astronomers were tracking distant exploding stars, using them to measure how the universe was changing over time. Gravity was expected to be doing its familiar job, slowly reducing the speed of expansion. The pattern should have bent one way. It bent the other. As the measurements arrived, those distant explosions appeared farther away than expected. The result repeated itself again and again. Expansion was not slowing down. It was accelerating. The discovery did more than break a prediction. It changed what the prediction was about. The problem was no longer just how far away galaxies might become. The problem was what happens when space itself keeps increasing the separation faster over time. A larger universe was one thing. A universe that changes whether information can still reach you is something else entirely. And if that process has already begun, what exactly becomes unreachable? Văn bản đã dán 1361 TXT. Tài liệu. The immediate assumption was that the problem had to be distance. If a galaxy is farther away, its light takes longer to reach Earth. That feels familiar. Wait long enough, and eventually the signal arrives. But the observations were pointing toward something less intuitive. Light was still leaving those distant galaxies. It was still traveling through space. Nothing had stopped the transmission. Nothing had switched the source off. Yet while the light was moving toward Earth, the space between the starting point and the destination kept changing. The journey was not taking place across a fixed distance. The route itself was expanding. Imagine a signal moving toward a target, while the path ahead continues stretching. The signal keeps advancing. The destination does not disappear, but the amount of ground separating them refuses to stay the same. That changes the problem completely. Distance is normally an obstacle that time can solve. A longer trip simply requires more waiting. The signal is delayed, but the outcome remains the same. Here, the situation begins to behave differently. Everything appears normal. The source remains active. The signal remains in motion. Yet the familiar rule that time eventually solves a distance problem no longer seems reliable. The failure is no longer at the source. The failure is no longer in the signal. Somewhere in deep space, a distant galaxy may still be sending an update. The update never arrives. And if the light continues traveling, what exactly prevents the information from ever arriving? For a long time, that answer seemed obvious. Build a better tool. Human history rewarded that approach again and again. A stronger telescope looked deeper. A deeper observation revealed objects that had been invisible before. What appeared empty suddenly filled with galaxies. Faint signals emerged from darkness. Structures nobody knew existed became part of the map. Each improvement produced the same result. More reach, more detail, more information. The pattern was so consistent that it became an expectation. When something appeared beyond current observation, the limitation usually belonged to the instrument. The universe was not hiding. The tools were simply not strong enough yet. So if distant information seemed difficult to access, the solution appeared straightforward. Build larger telescopes. Collect more light. Observe for longer periods. Push farther than the previous generation could. Nothing about those discoveries suggested a permanent barrier. Every successful upgrade delivered the same lesson. If something could not be seen today, a better instrument would probably reveal it tomorrow. Which made the conclusion feel almost impossible to doubt. But if that assumption is correct, why would any information remain permanently inaccessible at all? The assumption finally breaks when the limitation stops behaving like a technology problem. Imagine pointing a perfect telescope at a distant region of space, not a larger telescope, not a future telescope, a perfect one. The same distant galaxy is still producing new light. New events continue happening. The source has not disappeared. But there is a boundary built into the expanding universe itself. Beyond that boundary, new signals from sufficiently distant regions never complete the journey. The light keeps traveling. The galaxy keeps existing. Yet the information never arrives. Not because the telescope failed, not because the signal was too weak, not because observers stopped looking. The route between source and observer has changed in a way that technology cannot repair. That is the collapse of the old belief. For centuries, a missing observation usually meant there was still a solution. Build a larger instrument, increase sensitivity, wait longer, gather more data. Here, every one of those options fails. For the first time, the missing evidence is not hidden behind a technical limitation. The evidence exists. The observer exists. The connection between them is what fails. The consequence is difficult to accept. Parts of the universe can remain completely real while continuing to generate new events, new light, and new information. None of it arrives. But access to that information is gone. And once access to evidence can disappear, a new question begins to take shape. What does the universe look like when the amount of observable evidence keeps getting smaller? The final consequence is not that the universe becomes harder to study. It is that the relationship between knowledge and technology begins to break apart. Imagine astronomers inheriting instruments far beyond anything available today. Their telescopes collect more light. Their measurements become more precise. Their ability to analyze the sky continues improving. Yet the sky itself provides less information. That distant galaxy may continue evolving for billions of years, while none of its newer history ever reaches the observer. The missing evidence is not waiting for a future breakthrough. It is no longer arriving. Every generation may become better at observing the universe while having less of it available to observe. That creates a strange outcome. Astronomers can become better at observation while receiving less evidence from the wider universe. They can build more powerful tools while receiving less information from regions that once contributed evidence. Entire portions of cosmic history may remain beyond reconstruction. Not because the observers failed, but because the information needed to reconstruct them is no longer available. The universe still exists beyond those limits. Events still occur. Light is still produced. But observation depends on access, and access is not permanent. The discovery that began with distant supernovae ultimately revealed something far larger than an unexpected expansion rate. The greatest limitation was never distance. It was never telescope size. It was never the speed of travel. The deepest limit is not failing to find information. It is losing access to information that was once available to be found.